This is the exam review for semester 3. The subject is chemistry, grade 9. In semester 3 we started organic chemistry. We said organic compounds are made up of carbon, hydrogen and oxygen. These are the main ones, but other elements such as sulfur, nitrogen and phosphorus are also organic compounds. And examples of organic compounds are carbohydrates, proteins, lipids and plastics. We said that some inorganic compounds can contain carbon atoms, like carbon dioxide, carbonic acid, carbonate, and cyanide. Hydrocarbons are made up of carbon and hydrogen only. Okay, so hydrocarbons are made of only carbon and hydrogen, and they're divided into two groups, which is aliphatic. We said that aliphatic are straight chain hydrocarbons, and aromatic are circular. And then we specifically looked at the carbon atom. We said carbon is important because of two important properties. It has tendency to form infinite chains of carbon. So just as we drew before, this can go into infinity. Compounds are stable since the bonds between them are stable, and carbon has 4 valence electrons. Remember, carbon is C6, so that is the electronic configuration is K2L4. L4, that means it has 4 valence electrons. Bonds that carbon can form, they can form 4 single covalent bonds, just like in CH4. So this is 4 single covalent bonds. This is the first, this is the second, this is the third, and this is the fourth. Okay? It can form 1 double and 2 single, such as in C2H4. So this is the double bond. So remember, it's got 4 valent electrons, so it forms 4 bonds. This is the first one, this is the second, and this is the double bond. So 1 double bond and 2 single. So there's the 2 single for this carbon, and there's the 2 single for this carbon. It can also form 1 triple and 1 single. So for example, this is the triple bond, so this is 1 triple and 1 single. And remember, carbon can only make 4 bonds, so this is the first, this is the second, this is the third, and this is the fourth. Same for this carbon, this is the first, this is the second, this is the third, and this is the fourth. Molecular formula, it shows nature and the atoms in a molecule. It doesn't show bonds between atoms. For example, in CH4, C2H4, C6H12O6. Now this is, when we write it in this form, this is the molecular formula. The structural formula, it shows the nature and the bonds between atoms. For example, in C2, for example, if I was going to take C2H4, which is the molecular formula, the structural formula will look like this. So this is the structural formula, okay? This is the structural formula, while this is the molecular formula. Condensed structural formula, it doesn't show the bonds between C and H. For example, if I was going to write this as a condensed structural formula, I would write it as CH2, CH2. Okay, so this is the condensed structural formula, and it doesn't show the bonds between C and H. Classification of aliphatic hydrocarbons. Aliphatic hydrocarbons can be classified based on the nature of the bond. So, alkane family contains only single covalent bonds. Okay. So, for example, CH4, C2H6. Okay. So you can see that these only contain single covalent bonds. The alkene family contains double covalent bonds. for example, C2H4. Okay. Can you see here that this is a double covalent bond? Okay, so it's got two lines, while in here all of these have single covalent bonds. So just to go into more detail, the alkane family contains only single covalent bonds, are saturated molecules. The names end with suffix "ane". For example, we've got methane, which is CH4, ethane, which is C2H6, and they have a general formula of CnH2n plus 2. So for example, if we have a carbon which has, for example, 3 carbons, H2n, which is 2 times 3, which is 6 plus 2, so it will be H8. Okay, if we're going to apply the formula. So the alkene family contains double covalent bonds. They're unsaturated molecules. Their name ends with suffix "ene" and have a general formula of C2H2n. For example, if we're going to apply the C3 rule again, so it will be C3H, 3 times 2 is 6. And if we're going to draw this, it looks something like this. So 1, 2, remember carbon can only have 4 bonds, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4. So C3, as you can see, in H, 1, 2, 3, 4, 5, 6, H6. How to distinguish between alkane and alkene. So we put an alkane with bromine, there'll be no reaction. Okay, so bromine has a brown color, and when we put it with alkane, because there's no reaction, the solution will stay brown. But if we put an alkene with bromine, reaction occurs and decolorization occurs, so the brown color will disappear. And this reaction will occur due to the presence of double bonds. So, naming of straight chain alkanes. So this is what you have to revise. So you need to know that the molecular formula for anyone that has, for example, 1 carbon, it's going to be called methane. If it has 2 carbons, it's going to be called ethane. If it's got 3 carbons, it's going to be called propane. And this is only for straight chain molecules. And so on. So difference between straight and branch chain. In a molecule of branch chain alkane, not all carbon atoms of the same molecule are connected in this continuous straight chain. The internal carbon is bonded to more than 2 carbons, so either 3 or 4 carbons. For example, we've got butane. Okay, straight chain, 4 carbons. This is going to be known as butane. If I was going to put a methyl group on the second carbon, you can see that this carbon is bonded to 1 carbon, 2 carbon, and 3 carbons. This is known now as branched. Another example would be pentane. So it's got 5 carbons, so it's pentane. If I was going to put a methyl group on the third carbon, okay, for example, this carbon will have now 1 carbon, 2 carbons, and 3 carbons. Okay, this is also now known as branched. It's not straight anymore. Alkyl groups. This is when a hydrocarbon atom is removed from an alkane, the group of carbon and hydrogen atoms, which has a general formula CnH2n plus 1. The name of the alkyl is by changing the suffix ane to YL. For example, if I've got methane, remove the ane, will become methyl. So methane is CH4. When we remove one hydrogen, it will become CH3. This will be known now as methyl. So naming of organic compounds. Naming organic compounds was devised by a commission of the International Union of Pure Applied Chemistry. So that's what we call it, IUPAC. To find the IUPAC name of alkane, the following rules are followed. Alkane without branches, so straight chains, are named according to the number of carbon atoms. They are referred to as N-alkane. So for example, because this has 1, 2, 3, 4 carbons, it's known as butane. Naming of branch chain. The names of the branch chain alkanes are made up of two parts. We've got the substituted alkyl group and the main chain. So the main chain is always written as the second part, and the substituted alkali groups is named as the first part. The name of the second part is the longest and more branched chain. The first part consists of branching groups, the alkyls, just as we saw before. Show the location of the connected alkyl by numbering the carbons of the main chain in such a way that the first alkyl group receives the lowest possible number. Use the suffix di, tri if alkyl groups are identical. The alkyl groups are arranged in alphabetical order. For example, if we have a molecule that looks like this. We look at the longest chain first. So 1, 2, so this is 1, 2, 3, 4. Okay. If we're going to move like this, 1, 2, 3. This is, the numbers are less than 1, 2, 3, 4. So we use the one that has the longest chain. So this is the longest chain, 1, 2, 3, 4. Okay? And then we number each carbon of the straight chain. So as we said, this is 1, 2, 3, 4. And if we're going to move in this direction, it's 1, 2, 3, 4. This carbon, specifically, because it's got the alkyl group connected to it, you can see that either it's going to be the second carbon or it's going to be the third carbon. Here it says that the carbons of the mate chain in such a way that the first alkyl group receives the lowest possible number, and the lowest number here is 2. So how are we going to name this? We take the longest chain, and the main chain is the second part. So the second part we're going to write is butane, because it's got 4 carbons. On the second carbon, we always take number 2 because that's the lowest possible number. Is second, 2, put a dash, and because the second carbon has a methyl attached to it, we write methyl. So this will be named as 2-methyl-butane. Naming of haloalkanes. In the hydrogen, if the hydrogen is replaced by fluorine, chlorine or bromine, then the ending INA changes to bromo. For bromine, it will change to bromo, or chlorine, change to chloro. So we take out this part and we write O. So we take out the INE, we replace it by O. For example, if we have CH3, Cl, CH3, we take the longest chain, which is this chain, because it's got 3 carbons in a straight chain. This is propane. On the second carbon, there's chlorine, so you write 2-chloro. Remember, the longest chain is always the second part. Question 1 says, from the exam review, says ammonia is a colourless gas having a pungent odour that resembles the odour of urine. It is often sold as a ammoniacal aqueous solution found in cleaning products. Nitric acid is obtained from ammonia. Ammonia reacts with nitric acid to produce a compound, ammonium nitrate, which is used as soil fertilizer, which can be a frightening explosive. So the first question says, ammonia is made up of two elements, hydrogen and nitrogen. Determine the number of the fundamental particles of the nitrogen atom. So this is what we want, is the number of electrons, the number of protons, and the number of neutrons. Okay? So an atom is represented by like this, where Z equals atomic number, I'm going to write this down here just so you can see it better. Which equals the number of protons, which also equals 7. So now we've found out the number of protons in a neutral atom. Number of protons equals number of electrons, which also equals 7. Number of neutrons equals A minus Z, which equals 14 minus 7, which equals 7. Okay, so now we've got the number of protons, the number of electrons, and the number of neutrons. It says write the electron configuration of the nitrogen atom. So in a neutral atom, number of protons equals number of electrons, which equals 7. So the electronic configuration is K2 L5. 5 plus 2 equals 7. Indicate the placement of the nitrogen in the periodic table, the group, and period. So the nitrogen says indicate, so we don't have to justify, is in group 5. Remember, groups, we write them in Roman numerals because it's got 5 valence electrons, but you don't tell me that because it says indicate. So it's in group 5. And period 2. Period means row, so it's in period 2 because it's got 2 energy shells, so K and L. But please do not write that because it says indicate. Ammonia molecule. Explain the bond formation between the N atom and each of the hydrogen atoms in ammonia molecule. So we write a nitrogen atom needs 3 electrons to satisfy the octet hydrogen atom needs 1 electron to satisfy the duet rule. Each hydrogen atom shares a pair of electrons with the nitrogen atom forming three single covalent bonds. Then it says give the Lewis dot symbol of ammonium molecule. So it says give, we don't also have to justify, so it will look like this. The synthesis reaction of ammonia is represented by the equation N2 plus 3H2 2NH3. Show that this is an oxidation reduction reaction. So we've got N2 plus 3H2 equals 2NH3. So the oxidation number of N2 is 0, of H2 is also 0, and for H3, so for each hydrogen is plus 1, so that we've got 3 hydrogens, so the nitrogen is minus 3. Or we can do that by a calculation. From N2 to N in the NH3, the oxidation number has decreased because it went from 0 to minus 3. So therefore, this is reduction. From H2 to H, the oxidation number has increased, therefore this is oxidation. So we write the oxidation number of N decreases from 0 to minus 3. It undergoes reduction. H increases, so hydrogen increases from 0 to, or we can just write it as an arrow, to plus 1. It undergoes oxidation. Since oxidation and reduction took place at the same time, this is a redox reaction. 3.2 says identify, so we have to justify the reducing agent in this reaction. Hydrogen is the reducing agent because, so this is how we justify, because it undergoes oxidation. So then it says pick up from the text 2 uses of ammonia. That is the soil fertilizer and cleaning products. Question 2 says compound A is an important raw material in the industry of polymers such as polyurethanes, which are used to manufacture furniture, mattresses and car seats. Polymers are widely used because they have better properties than natural alternatives and are cheaper. The Lewis dot structure of the molecule of a particular organic compound A is shown in figure 1. Here it says use the information given in figure 1 to answer the questions 1, 2, 3 and 4. Write the molecular compound of A. So we look carbon, it's the black colour. So we've got 2 carbons, we write C2. Then we look at hydrogen, so hydrogens are these, the white balls, and then we've got 3 hydrogens. So this is the first one, this is the second one, and this is the third one. So we write C2H3. Then we look at nitrogen. Nitrogens are the ones that have kind of an arrow in them, and this is it. So you write N. And oxygen is the one that has these striped molecules. So this one here, and we've only got one of these, so you write NO. So this is how we write the molecular formula. Question 2 says indicate the type of bond between the nitrogen atom and each of the carbon atoms in a molecule of compound A. So we look, where's the nitrogen atom? It's here. So this is the nitrogen atom and these are the 2 carbons. So we look, this is the first carbon, so we look at the bond between this carbon and this carbon. So we write the nitrogen carbon bond. And you can see here is a single covalent bond because there's only one line, and between this nitrogen here and this one here we can say that, see there's 2 lines, so it has to be, so the nitrogen carbon bond here is a single covalent bond. It's not single, it's double. Here it's double covalent bond. Then it says the nitrogen atom is bonded to 2 carbon atoms and has 2 electrons in its valence and energy shell, which is not involved in the bond formation. Non-bonding electron pair. Determine the number of valence electrons of the nitrogen atom. So here we say the number of valence electrons of an atom is the number of electrons in its outer energy level or shell. So first, in the single covalent bond, nitrogen atom gives 1 electron. In the double covalent bond, nitrogen atom gives 2 electrons. Also, there are these 2 lone pairs here. Can you see them? There's the first one, this is the second one. So there are 2 electrons not involved in bonding. So the number of valence electrons is 1 plus 2 plus 2. So it's 1 plus 2 plus 2, which equals 5. Okay? Question 3 says functioning of galvanic cell. A galvanic cell is a device that converts chemical energy into electrical energy due to the spontaneous redox reaction. The adjacent schema, which we're going to see in the second slide, represents a functioning galvanic cell. So the first question says label the numbered parts 1 and 2 of the galvanic cell. So number 1 is here. So the number 1 is the iron strip, because it's got here Fe2+, so we know Fe2+ is iron. So 1 is iron strip. 2 is here, and because it's Cu2+, so we know that Cu is copper, so the 2 is copper strip. Indicate the anode of the above galvanic cell, and we have to justify. So iron strip is the anode. And how we know that the iron strip is the anode, so we can see the flow of electrons going this way. So because the electrons move from the anode to the cathode. Write the half reaction that takes place at the anode. So we said that the anode is the Fe, so the half reaction is Fe, and it goes to Fe2+ plus 2E minus. And remember, in the anode we always lose electrons, okay? So it was Fe, it lost 2 electrons to become Fe2+. So oxidation has taken place. Here it says, question 4 says the equation of the overall redox reaction of the functioning galvanic cell is, deduce the half reaction that takes place at the cathode and the anode. Now here we have to work the opposite to what we normally do. So we just write the equation of the anode. Now to make it easier for us, we're going to reverse it, okay? So we're going to reverse the anode. So that will be Fe2+, so we're just reversing it. we know that the overall reaction is Fe plus Cu2 plus equals Fe2 plus Cu. Now if we take the things that are in common, we've got Fe2 plus here, Fe2 plus here, we've got Fe here, and we've got Fe here. Then we write things, so the cathode, then we write the things that we have before the arrow and after the arrow. So we've got Cu2 plus 2e minus equals Cu. Here it says, during the functioning of the cell, the quantity of F2 plus ions vary in a solution A. Compare the amount of F2 plus ions in solution A before and after the function of the galvanic cell. So the amount of Fe2 plus ions in solution A is greater, because remember the ion strip is losing electrons. So if it's losing electrons, Fe2 plus is increasing, is greater than the amount of Fe2 plus ions in solution A before the functioning of the cell. Specify the ions that migrate from the cell bridge towards solution A to maintain the electroneutrality. So because we've got a greater amount of Fe2 plus, we've got this positive charge which is increasing, we have to neutralize it with a negative charge. So it's going to be the nitrate ions so the NO3 minus, because, so it says specify, so we have to justify, because the quantity of Fe2 plus ions in solution A increases during the functioning of the cell. Question 4 says, petroleum is a mixture of hydrocarbons. Petroleum should be treated before its use. During the refining process, hydrocarbons A and B are obtained. The following graphs 1 and 2 show the number of carbons and hydrogen atoms in the molecule of A and B. So it says, number 1, refer to the graphs 1 and 2, verify that the molecular formula A is C2H4 and that of B is C4H10. So for A, from graph 1, the number of carbon atoms equals, so we look at A, the number of carbon atoms is 2. From graph 2, number of H atoms equals 4. So here the number of hydrogen atoms is 4. So then the molecular formula is C2H4. That's for A. In B, so again we do exactly the same thing from graph 1. Number of carbon atoms equals, here look, B is 4. From graph 2, number of hydrogen atoms is B. Here look at B, it's 10. So here it's 10. Therefore the molecular formula is C4H10. Then it says identify the family or class to which each of the above carbons belong to. So if it's an alkene or an alkane, A, we saw that it is C2H4 from the previous slide. So this is an alkene, as it satisfies the general formula CnH2n, and B, which we saw it was C4H10, is an alkane, as it satisfies the general formula CnH2n plus 2. Question 5 says, organic compounds and inorganic compounds are employed in our everyday life. The list given below shows the formulas of some organic compounds. So there's the list. Copy the table given below and use it to classify the above given compounds into organic compounds, hydrocarbons or not hydrocarbons, and inorganic compounds. Hydrocarbons are molecules that have hydrogens and carbon atoms, so we just look at the ones that just have carbon and hydrogens. So the first one is CH4. So the B's got oxygen in it, C's doesn't have carbon, D's got oxygen in it, E just has carbon and hydrogen, so we write C4H10. F has C2H4, and G is CaCO3, so it's got oxygen in it. Non-hydrocarbons, so that's mainly, let's do the organic inorganic compounds to rule out. So we've done CH4, we've done C4H10, and we've done C2H4. Inorganics, remember we said that carbonates, so in CaCO3 is an organic compound, and ammonia is NH3 is an inorganic compound. So the rest are not hydrocarbons, so that will be C2H5. They're still organic, but because they're not composed of carbon and hydrogen atoms only, we call them non-hydrocarbons. So that is C2H5OH and CH3COOH. Compound E is an alkane. The carbon atoms in a molecule of E may be connected to each other according to 4 representations given below. Indicate whether each of the 4 given representations stand for straight chain alkane or stands for a branch chain alkane. So, straight chain alkanes. So here, because it's in a straight line, that's a straight line. So number 1 is a straight chain. Okay, so number 1 is a straight chain. Here as well, because we can see that there are no branches, number 2 is also a straight chain. Number 3, also we can go in a straight line, is a straight chain. But number 4 as you can see, if we go in a straight line, they will have a branch here. So this number 4 is branch. So 1 and 2, 3 are straight chain alkanes because each carbon is not bonded to more than 2 carbon atoms. 4 is a branch chain alkane. As you can see, this carbon is bonded to, this carbon here is bonded to 1, 2, 3 carbons. So because carbon alkane, because a carbon atom is bonded to more than 2 carbon atoms.